Good morning, students. This is the unit about measurement. So, in last class, we discussed about vernier caliper, how to measure the inner and outer thickness of the given objects. So, if the object is little huge in its thickness, it's bigger in thickness, there we can use vernier caliper. So, what is the construction of the vernier caliper? How to find the errors? How many types of the errors? If error is there, how to rectify that, how to handle that. So everything was discussed in previous classes. Now next measuring instrument is a screw gauge. We are going to discuss about screw gauge. So this screw gauge will give the thickness value of minimum thickness of the objects. So in vernier caliper, the object's thickness will be little bigger. If it is very smaller means there we can use the screw gauge, and here the diagram is given for screw gauge. See in this diagram, so there is a U shape. Can you see that U shape? Yes, there is a U shape. So this U shape metal frame is attached at one end of the screw gauge, and here there is a ratchet stop. This screw gauge have to handle with this ratchet which is given here. We'll rotate using that part, and see here this is head. On this head we having a divisions of 100 divisions are there. So this division is placed like a rolling one. So this head with the scale is called as head scale, and see left side of the head scale there is a flat scale is there. It starts from 0, 1, 2, 3, 5, 6, 7, 9, 10. So 0, 5, 10 are printed there. That is called as pitch scale. And there are two screws or two studs, we can say. This is one, this is next one. So while taking reading or while finding error, we'll use these two studs bring to contact. And now this spindle screw is extended, which is placed inside the hollow cylinder. This is the hollow cylinder. And here the head scale, when we are rotating the ratchet, the head scale is also rotate. At the same time, this hollow will move towards the U-shaped metal frame. This is about screw gauge. Using this screw gauge, we can measure the value of thickness up to 0.01 mm. So very least value, just compared to the vernier caliper, this screw gauge will give smallest value. We can measure up to very smallest value in the value of 0.01 millimeter. And this is about screw gauge description. And next, see here, using of screw gauge. So what principle we are using in this screw gauge is, when we are rotating the ratchet or when we are rotating the screw, the distance moved by the tip of the screw is directly proportional to number of rotation. So how much rotation we are made, that is directly proportional to number of the distance moved by the tip. That is the principle used in the screw gauge. Then pitch of the screw. This pitch of the screw is nothing but the distance moved by the tip of the screw for one complete rotation. So when we are giving one complete rotation, it means the starting value is 0 of the head scale. We are giving complete rotation. So again the 0 comes to the same position after one complete rotation. At the time on the pitch, where is the pitch scale? That flatter one. How much distance it covered for one complete rotation, that is called as pitch of the screw. That we can calculate with the formula of distance moved by the pitch divided by number of rotations by head scale. This is a formula to find the pitch of the screw. Then least count of a screw gauge. So about least count we discussed in previous section, in previous topic. Least count is nothing but the given instrument can measure least value, that is 0. So all the instruments value will starts from 0. You don't worry about the 0. After 0, what is the minimum value we can measure using that particular instrument? That is called as least count. So in this least count, how to calculate the least count of screw gauges? It will be taken the ratio between the value of one smallest pitch scale reading to total number of head scale division. This is the formula to find out the least count. At the same time, the tip of the head is moving for one, after one complete rotation, it is moving for one division, and the head scale means that is called as least count of the screw gauge. That we can calculate 1 divided by number of divisions on the head scale, that is equal to 0.01 millimeter. This is the least count of the screw gauge. And next, zero error of screw gauge. In this also there are two types of zero errors. One is positive, next one is negative. How to find this zero error? So in diagram we saw here there are two tips. See here in this picture, in this screw gauge, there are two studs are there, and that studs gap is filled here with the arrow mark, red color arrow mark is given. So using the ratchet or using the screw, we are rotating. The head is moving towards the U frame. In between the two studs, nothing will be kept now. So we are rotating the screw until the two studs will become contact. So when these two studs contact to each other, so at the time here one sound will come, we have to stop rotating the ratchet. The two studs now contact. At the time, what we have to notice is this part will play the important role. So how many scales are there in my last circle? How many scales are there here? Two scales are there. One is head scale, that is this circular part, and next one is pitch scale, this horizontal one. So these two scales will be compared here. So when the two studs are contact to each other, the zero of the head scale is exactly lying with the pitch scale. That line means we can say there is no zero error. Have you understood? The zero of the head scale is exactly lying, exactly straight to the pitch scale means we can say there is no zero error. So here the zero error is nil. Understood? We are rotating the screw. இது வரைக்கும் ரொட்டேட் பண்ணுறோம். ரெண்டு ஸ்ட்ரெட்ஸும் காண்டாக்டில் வர வரைக்கும். எந்த ரெண்டு ஸ்ட்ரெட்ஸ்? யூ ஷேப், யூ ஃப்ரேம்குள்ளே இருக்கிற ரெண்டு ஸ்ட்ரெட்ஸும் காண்டாக்டில் வர வரைக்கும் நம்ம ஸ்க்ரூ ரொட்டேட் பண்ணிகிட்டே இருக்கோம். அண்ட் ஹெட் ஆஃப் த ஸ்கில் இஸ் மூவிங் ஃபார்வர்ட் டுவர்ட்ஸ் யூ ஷேப். இப்போ ரெண்டு ஸ்ட்ரெட்டும் காண்டாக்டில் வந்துருச்சு. வந்ததுக்கப்புறம் வாட் வி ஆர் கம்பேரிங்? ஹெட் ஸ்கேல் 0 அண்ட் பிச் ஸ்கேல் லைன். We are comparing that. If the head scale 0 is exactly straight or coinciding with the pitch scale, there is no 0. So what is the 0 error there? We can say it is nil. Okay, and next we will see other two types of error. This is called as no zero error. Then we will see the positive zero error. In the positive zero error also same thing we have to do. We are rotating the screw. The screw head is moving towards the U-shaped frame. And now two studs are contact to each other. Then after contacting, we are comparing the head scale and the pitch scale or a flat. Pitch scale on the values நம்ம பார்க்க மாட்டோம். Flat line மட்டும் consider பண்ணுவோம். And see this figure 1.7. You see this area. This line. I draw one line. Above that one line is there. That line is matching with 5. Right? So 5 is the value on the head scale. This 5, then 10, and below the 0 is given there now. These values are on the head scale. And now that straight line. So here there is a straight line now. and this straight line is nothing but pitch scale line. And now the head scale 5 is coinciding with that, not 0. So when the 0 error is nil, the 0 of the head scale should be coinciding with the pitch scale. But here it is not happening. What happening here? Here 0 goes below to the vernier. 0 இங்க இருக்கு, கீழ இருக்கு. எதுக்கு கீழ இருக்கு? இந்த vernier scale, sorry, pitch scale க்கு கீழ லை ஆயிருக்கு. And this error is called as positive 0 error. So 0வும் pitch scale straight match ஆயிருந்துச்சுன்னா there is no problem. But here it is not matching. This 0 lies below the pitch scale line, then this error is called as positive 0 error. Okay, எல்லா வெர்னியர் எல்லா ஸ்க்ரூ காஜ்லையும் பாசிட்டிவ் எரர் கம்பல்சரியாக இருக்குமா அப்படின்னா, ஸோ while buying a new one we can check that maximum there is no error. ஸோ ஆஃப்டர் டே பை டே, ஸோ எப்படி நம்ம வெர்னியர் கேலிப்பர் டிஸ்கஸ் பண்ணிக்கிட்டோம். ஸோ டே பை டே நம்ம யூஸ் பண்ண அண்ட் ஒரு சிலர் ராங்காக ஹேண்டில் பண்ணுவாங்க. And so that they don't know how to handle, how to rotate that screw, how to fix that object. அப்படி இருக்கும்போது, அப்படி மிஸ்டேக் பண்ணும்போது தான் these errors are occurring. And if it happens, what correction we have to give is, we have to use this formula. 0 error is equal to n into LC. LC we calculated. LC is nothing but least count, 0.0. Yes, LC we know. And what is n? So in this figure 1.7, pitch scale straight, which value is lying? Yes, 5. Suppose this 5 is down straight to that 7 அப்படினா, so 5 க்கு அடுத்து வருதுல, so 5 க்கு அடுத்து வர first line is 6. I am saying towards top. Then second line 7, 8 அந்த மாதிரி தான் எடுத்துக்குவோம். Suppose 7 is lying straight to the pitch scale na, we have to take n value as 7. So for this diagram, what is the n value? It is 5 in this figure 1.7. Then we can substitute in correction 5 into 0.01, that is equal to 0.05 mm. So this is 0 error. We have to give correction. This is what kind of 0 error? Positive 0 error. If it is positive means same like vernier caliper, in correction this 0.05 mm have to written with minus 0.05 mm. So keep in your mind, don't forget, if positive error in correction we have to put negative symbol. Okay, so here the 0 correction is minus 0.05 mm. This is for positive error. And next we will discuss about negative 0 error. Negative 0 error is like same positive but little bit opposite. And see the diagram figure 1.8. It is representing the 0 error for negative. And see the diagram. In this diagram itself you will understand, because we know when the 0 error is nil, when that is called as positive 0 error. So from this diagram we can learn easily that. And see, we are rotating the screw, 2 studs have to contact to each other. After contacting the 2 studs, we have to check the pitch scale and main scale, that is head scale. And pitch scale line and head scale line are coinciding, and we have to check which value of the head scale is coinciding with the pitch scale. And see in figure 1.8, it is 95. You can see that the 95 is the head scale and this line is pitch scale. So straight to the pitch scale 95 is coinciding, it is not 0. This error, so 0 is lying above the pitch scale, then this error is called as negative 0. So which line is coinciding? 95. And here there is a formula, little different formula as compared to the positive 0 error. What formula is? This formula we are using. 0 error is equal to minus of 100 minus n into LC. We have to throw this formula. Then 0 error is equal to, we are substituting. So in this diagram, what is the n value? Small n value? Yes, 95. Then we are substituting. 100 minus 95 is 5 with the least count. Minus 0.05 mm we are getting as 0 error. And for correction, this is what kind of 0 error? Negative. Then for correction, we have to put opposite sign. Negative means we have to put plus 0.05 millimeter. This is the correction for this negative 0 error. And next there is an activity, and in this activity they given how to find the single sheet thickness. So that we'll discuss after our practical. In lab we'll do this experiment using screw gauge. So after handling the screw gauge it will be easier. So when we are doing in lab we'll do this method only. So we'll do this activity too in lab. And next topic is measuring of mass. So what is mass? So generally we are using in our daily life உன்னோட weight என்ன அந்த பேக் ரொம்ப வெயிட்டாக இருக்குது, like that we are saying. So in many cases instead of weight and instead of mass will change the terms. Mass யூஸ் பண்ண வேண்டிய இடத்துல weight யூஸ் பண்ணுறோம், weight யூஸ் பண்ணுற இடத்துல maximum we are not using mass term. Sometimes in misunderstanding we are using. So we'll see what is mass, what is weight, what are the difference between that அப்படின்றத we'll see in upcoming class and upcoming topic. And what is mass? So mass is nothing but it is unit is kilogram. So this mass is amount of matter contained in a body is called as mass, and this mass is measured with the value of milligram, kilogram, like that. We'll use that in jewelry shop. We'll use gram. No, in milligram also we are using some point something is there, like that. In physics laboratory we are using. So when we are using with the gram or kilogram with unit means that is mentioning mass. And where we are using that common beam balance, this common beam balance we are using in shops to measure the mass of the objects. See the figure 1.9. when we are going to the shop, so we want to buy sugar or rice or whatever it is, means one plate which is kept by the stone, the next plate is filled with that sugar or some other commodities. And we can measure when the middle needle is showing the exactly balanced, that time it will be straight and both the plates will be equal height, and we can measure the mass. And this, using this common beam balance, you can measure the values 5 gram, 10 gram, 50, up to 5 kg you can measure as accurate one. And next one is physical balance, and this physical balance we are using laboratory. In physics and chemistry lab we will use this. So while preparing the solution, when the salt is mixed with water, or when we are doing some other experiments, we need accurate weight. So in that case we are using this. This physical balance is also like common beam balance, but it is most sensitive than the common beam balance. So only it is kept inside the glass door. Even the blowing air can disturb the accurate mass of this physical balance. Okay, this is about physical balance. And using this physical balance we can measure the mass from 10 milligram to up to 200 grams, not more than that. And next, digital balance. Nowadays in all shops we are using this digital balance, and this digital balance is giving the accurate measurement. Using that we can find the mass of the given object. So in olden days we used beam balance, and nowadays the beam balance was replaced by this digital balance. So just when we are keeping the object top of the plate, and there is a digital screen that will show the accurate value of the mass of the object which one kept on the plate. This is about digital balance. About this you may all know, in jewelry shop we are using, and in roadside shops when we are buying vegetables and some other commodities in shops, we can see this digital balance. And the remaining is spring balance. This spring balance mostly in some shops we may see, and this spring we can see this is spring balance, figure 1.12. and this, using this hook will hang the object which one want to measure the weight, and will hold this holder. And this when we are adding the weight, this spring will move down. There is a spring here, and there is a scale with values. So after pulling down it will shows the value on the scale. The spring balance is used to find the weight. And next is difference between mass and weight. About this we will discuss in next class. And you mark for today's homework both the types of errors, positive and negative errors in screw gauge. That one you study and understand and write in your homework note. Okay, and remaining we'll see in next class. Thank you, students.